developing a software, if you are developing a software that needs to handle also solar temperatures, you are correct. Yeah, it doesn't work like that. But even Andrei, as I said, if you use i8, i8 is like 120 minus 128 and 127. So it covers.
Yeah, yeah, yeah.
It's
Yeah,
covered. So I was not way off.
yeah.
But
Otherwise,
but but yeah, I
probably
got
you're dead
you're dead already. Yeah.
around outside of those temperatures.
But by the way, you should because this is I actually had a discussion with someone about this, explaining the humidity in the air. So how the humidity affects let's say the temperature outside. So for example, if it's very cold or very hot, if you have even more you have a lot of humidity in the air, these very hot and very cold uh, are amplified. So you feel even hotter or even colder because the humidity actually makes the transfer, the temperature transfer between the bodies, let's say your body and the medium outside, more efficient. So, for example, if you are in a hot sauna, like a dry sauna, no, dry sauna, how it's called, so it's not the wet sauna with water, you can get to 90 degrees because the air having less humidity, the air by itself is not so good temperature transmitter as the water. So the air having less humidity doesn't transmit the I don't know. Can you hear me? Sorry.
Yeah, yeah.
I was because he's using the microphone for my laptop, but I go to the other room, and I'm not sure. Okay, so the idea is that if you stay in the low humidity like the hot sauna, dry sauna is, you can stay at 90 degrees because there is a lot of losing transfer, so not a lot of that 90 degrees bring gas to your body. But if you stay in the wet sauna where I don't know humidity is maybe 80% or I don't know very much, then if you make it like 90 degrees, you actually have very close to boiling point. I mean, much of that 90 degrees gas to your body because the water is very good transmitter. So in that case, you can actually see how the humidity affects how you feel the temperature. And in places where I know Barcelona, where is also a high humidity, the same temperatures get you most discomfort, more discomfort than other places where there's less humidity. The same temperature. So
Yeah,
both
Mhm.
are relevant to how you feel, how the comfort is for you.
No, I coming back to the program. I have one more question because I don't understand what kind of error you had uh, when we after we added the epsilon, but the if with the hits was separated. So
Oh,
the
okay.
program ended with some kind of error, and it's
Uh,
not very clear what error was that, or is it was it
like it
coming
wasn't a
from?
compile time error. You mean like it
Ah,
just the program didn't work, right? That's
no,
what you mean.
it started. The program started and printed something,
Yeah,
and
when
then
you
it
when you had all those prints, but it didn't print in 9 or whatever remain.
yes,
Why
and
why
the
did it?
program ended with some error, but
Yeah,
it's not
error
clear.
abruptly. Yeah.
Oh, I just I use Control C.
Ah,
You stop it. Okay, okay.
Yeah,
Because
yeah, yeah. Because
it
there was
is
no point. It was an interrupt.
oh,
understand.
so but it was displayed in a very weird way,
Yeah, it
like
is. I
a
it
program
it it,
error.
it, it was not obvious for me either. Can you do it again to just
Yeah, I'm
to
gonna try doing giving it some value that it cannot reach.
cannot
You
reach?
know, let's say 10, and it works now. You just don't see it because I don't have the prints, but now it works. I know because of my fan on my PC that it's going crazy. I can just Control C out of it, and
Error.
this
Yeah,
is
that's the strange because it's kiss error. Okay, status control C exit. Okay,
yeah, exactly, yeah.
exit. But okay, exit. Why is exit code? Okay, what's that? Can you copy that and use Google or something? Just make it decimal. 1 3 is
This one.
1 3. Yeah, make it decimal. At least by my head, because you have the C at the beginning, so I cannot convert that by my head.
I can just,
Very very smart.
it should. Oh no, it's out of range. But can we do like there?
Maybe you can add a suffix. Oh,
It shouldn't be out of range anyway. Like, but whatever. I'm not sure why. Yeah, so there it is. Oh my god, it's
What the fuck?
huge.
What?
Oh no, it's the C here. It was
Sorry, man. Like, yeah, that's what I say. I cannot because okay, 13A. Maybe if I think a bit, I can translate it to decimal. But
this.
the C there, I cannot. But the why the exit status is so big? So three. So it's
Well,
not
it's not
even.
the return, the normal return.
I
It's
know,
because of
but
the control C.
no, I know. But why would they associate? Because that's exit status. Why would they associate this number to control C? I mean, why not? Because it's an expected status that you would end up with, right? Control C. Somehow it's an expected status. Why would you assign so
but it's
out
a
of?
constant. You have a constant for it, no?
I understand, but what's the value? What does that mean?
Yeah, I don't
Can you
know.
look that on Google? Can you look this
Yeah.
the hexa? No, the hexa value.
This one.
This one.
Rust.
No, not Rust because just
Oh,
do
just this?
generic. Yes, okay.
Yeah.
Yeah. So okay, so this you see this is the constant indeed, but why would it mean this value? Control C. Okay, C. I'm trying to find a pattern like C is from control and 13A is from some kind of other C. Like control plus C. Just thinking out loud. Yeah. Why? 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 Why for why is this for yeah for terminating a program by control C. Yeah, it's okay, it's okay.
Okay, it's not saying like.
I'm not saying anything useful. Why this value but not other? Yeah, exactly. Why this specific value?
Oh, okay. So it's like a Windows thing, obviously.
This part of the C negative status, the specific reason. Okay, the specific reason code. Okay, this makes
Okay.
sense. This makes sense. So C indicates there's an error. Okay. Okay, so that's the
So when you
pattern.
have zero C,
It
zero
means
X, so
error.
it's
Yeah, it
like
means
a
error.
severe
Okay.
fatal error
So
in
so
Windows.
maybe if I run this on Linux, I have a different value there. Okay.
Of course, yeah.
Yeah, and then this is 314. Okay. So it makes sense that now. Okay, so it's the pattern is the first is an error, the other one okay is from the table. Okay, this is how they define them.
Because
Three
this
point
isn't
in.
really that big, so it makes sense.
No, yeah, it's not a big one, but it's interesting that it's 3.14 is like pi. I don't know if I just making connections in my head. Ignore
Yeah,
it.
no, it's
Maybe they don't make any sense, but this is how my brain works. I keep making connections.
yeah.
Yeah, okay, so yeah, so it's the number of error and the C is the error.
And C
Yeah,
comes from circle.
circle. Yeah, that's why the pi. Huh? So the is like the C is like the circle that it looks like the circle, right? The C, and then the pi is obviously because of the circle, and then somehow control would be the length of the uh how do you call arc of circle maybe. So how
Uh,
many how much length
length.
is length of yeah, but
Yeah.
the length of the
Perimeter. Perimeter. Or-
yeah, but the arc of circle, I mean, how much is from the circle between I don't know, angle one and angle two, like radian one and radian two. So how much is that value?
yeah.
For sure, is not related to this. these are these are
Probably not.
these are just not a problem. I think most likely, and these are just aberrations that. For example, what I noticed. So sorry now, I just keep speaking other stuff. So what I noticed with a friend of mine is we worked together many times. Like I don't know, somewhere in the city or something. And when we were quite tired and it was late in the night, and what we noticed that our brain, the defense mechanism for tiringness. So, like for example, if you when you feel asleep, you see that you how do you call Andrei Kaska? When you feel asleep, you open your mouth and take air in. How do you call that action? I don't.
Yeah, I don't know.
Okay, let me
I don't know it from my head.
top of my head. Let me translate it. To yawn, to
Like
yawn,
yawn?
yeah, to
Yeah.
yawn, yeah, exactly, yeah, to yawn. So when you yawn, what's exactly happening is your body has a lot of more oxygen than normally you are breathing, and the way that you do also your body somehow contracts the muscle, so more oxygen reaches your brain, and somehow it wakes you up, or makes your brain more active and gives you this feeling of waking up because your body wants to help you. Okay, if you didn't decide to go to sleep as your eyes are still open, you have your reasonings, so it doesn't understand why, but it tries maybe you are running from an, I don't know, a lion or something, so it's not a good time to sleep.
Oh,
Okay.
for sure you'll not yawn when you're running from a lion.
Yeah, probably not.
Okay, maybe you are bored and you're feeling asleep and you see the lion and
Oh, this lion is so slow. Let's yawn a little.
no, but the
Wow,
idea is that
what a boring
if
lion.
no, but the idea is you no, the lion didn't yet come, so you're staying on somewhere, you are just relaxed and you feel like asleep, and then you see the lion, so you are barely going to sleep, but you see the lion. So in this situation, it will help you to wake up a little bit. So then you yawn, you know, so that you wake up so that you can run more efficiently. So.
Yeah.
Uh, there are okay, there are situations like this where actions that your body does help you to, let's say, improve your cognitive situation. And what you observe with my colleague was that in situation like we were very tired, so not exactly feeling necessarily asleep, but we were tired, but we still had to work, so we stayed awake and we still continued to work. We observed that if we just speak stuff without so much sense, let's say aberrations, I mean, not without sense because it's not correct. So like aberration, like we did, like now, so I just try to find patterns that maybe are not there, so but I try to use my logical mind in a way that is not somehow tiring, but it's more like reviving, like fun, because having fun makes you laugh, increase your dopamine, for example. And if this gets increased, you are also more efficient in your cognitive processes. So we actually observed that if we did like a lot of jokes and we a lot of aberrations, it helped us laugh, and then we could work more. So like somehow the yawn, but at a cognitive level, let's say, intellectual
Mhm.
level.
Yeah. So is this like an okay program, but like from a beginner, like I don't know. I
Okay, so
started like 2 weeks ago or something like that, 3 weeks.
I think for a beginner is very okay.
Okay.
So you
I
started
think.
to program 2 weeks ago?
No,
No,
Rust.
Rust, yeah.
No, in
But
Rust, like
because you can see that you have experience. But what languages and how long have you worked?
no, like C. Like I'm third year college right now, so obviously C. C
Mm-hmm.
from like obviously the C++ we do here in high school in Romania. We do some sort of C++, but it's actually C. And then in like I have like 4 years of C experience. I also have some projects like graphical projects in C. Other than that, some Java, but I don't like Java. No offense, no offense. It's just I don't like it that much. Um,
Lately, me neither. Relax. So there's no offense. I had
okay,
experience in
okay.
Java because that was the circumstances. But at some point, I felt that I don't like so much this Java. I actually feel that the Java needs to change. So the Java is very obsolete
It's
actually as a syntax. So they try to
yeah,
take various aspects from other programming languages, but they actually need to do what Apple did. So they just Apple discarded Objective C and just
yeah.
created a new language which is Swift. And by the way, just a remark, note, the the guy who I don't remember the name, I got good names. The guy who created Rust actually now is working at Apple on Objective on Swift, and actually you can see some aspects from Rust
Rust. Yeah.
in Swift. So it means that they appreciate, they give the appreciation to him, because why not? Wouldn't you give an appreciation to a guy like this who created
Yeah. Yeah.
such a beauty? Yeah, so I think more than you emphasize the fact that you ask for a beginner. I think for a beginner is very good program. So the the let's say the remarks that at least I made were just in the realm of optimizations. So
Mm.
it's not something
Yeah.
that
Yeah.
okay,
Yeah.
your program is not good or stuff like that. So it's, yeah, I think it's really okay, really good. And like you said that you didn't even start with this, because I think you mentioned you started with the second program, right? Or stuff like that.
Oh no, no! I started with the first
Ah,
program,
okay, okay. But you
and
said
then
you
I
you
moved.
you you, you
Yeah.
did the second one also. Yeah, okay.
Yeah, it works okay. I didn't use any. I just used the prelude. But I have a quick question. After that, I'll have to go, unfortunately. But I have a quick question before I go. Um.
Yeah, sure. Yeah.
So yeah, sure, you can.
No, no. I mean, yeah. Go ahead. I was thinking. I was trying to say that I think, yeah, we should also maybe finish after that, and
Hmm.
maybe
Sure,
resume
yeah.
on the chat and on the, yeah, on the chat, and if needed we can have individual calls, or I don't know, we can anyway we'll resume it next time. We will continue the reviews next time, because yeah, it's kind of late for everybody.
So I've noticed that if I make a quick vector here, oh, that's bad habit right there. Like C++ habits, not
Indeed,
this.
yeah, indeed. Yeah. Also Java,
Um,
relax.
Also Java, yeah, and C sharp and whatever.
Yeah.
So if I try to iterate through the vector, and I only want to not to take ownership, just have a reference, I can do that, which is okay. Like I understand this, but what
Okay.
if I want to use the thing where I have this? Because usually, I do this and enumerate, but I would like this takes ownership, and I don't want to take ownership. Is there any way I can do this so I can have the index and the
What do you mean?
value?
What do you mean it takes ownership? Because it doesn't. Because you still
It
have
doesn't.
no. Because you still have the pointer to it. So if you do into iter, just do into iter. Just write
Like
into
that.
iter.
Are you
This
sure?
actually, yeah, this actually, if you look, this actually will
Oh yeah.
actually,
Hmm.
this will actually
Hmm.
drain your, this will actually drain your vector. This will actually empty, as long as, I mean, as it iterates through it, it will remove the elements from the vector.
Oh, okay. I thought it
You
takes ownership in this
No, no,
case
no, no, no,
because
because no, no, it doesn't take, because first hint is look at the type, so it's still a
yeah, yeah,
reference, and just
yeah.
print after that. Just put an element in the vector and print it
Oh, what I
after the for.
did try was to. Oh, it didn't work because I was. Oh no! Now I know. I
Ah,
tried to
but
modify it.
yeah, yeah, but you
You
cannot.
know,
Okay,
because this actually does that, and I have
exactly.
a reference here, and it's the opposite way. But yeah, now I see.
Here you have an immutable reference, and you cannot
Yeah.
have a mutable one. So that, like, yeah, like we discussed before, you
Mm,
cannot have
yeah, yeah, yeah.
a mutable one while you are having other immutables ones.
Yeah, makes sense. Makes sense.
Yeah, yeah, yeah. And actually, you'll see later on. So the idea, all this sugaring, like if you call, okay, if you call iter, you expect that something happens behind the scenes. But if you just do in v, like you do there for x in, for example, just remove from the first four, remove the adversant. You see, it's I32. So this is like, if you, so behind the scenes, what's happening? So you have, there are few traits that you can implement on your structure that makes them iterable. And for example, there is one into iter, which actually has a method, okay, called into iter. And actually, this is what this sugaring behind the scene does. When you just do in v behind the scenes, if it see that you can only do this if it implements those. Yeah, it's the same. So behind the scenes,
Oh,
it
okay,
it
okay.
it, call,
Mm-hmm.
it calls this method. Yeah, exactly. It calls
And
this method.
obviously, I cannot print now because it's moved here.
Yeah, 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 yeah. It's yeah, correct. You're right. It's move, yeah, because that method, though, that's also one difference. So into iter
Mm-hmm.
actually moves And if you do
But
iter,
if you move it after the for, if you move the printing the vector after the for, so
it's
No,
a,
that should be fine.
yeah, but it's empty.
Oh
And
yeah, so it's
maybe you can
out of scope.
maybe you can even, yeah, because
but
into iter moved it into the function, so the function doesn't
Yeah.
return it outside, because it makes sense, because this actually consumes the vector. This is what it does. This actually by default consumes the vector, so whatever is used inside it doesn't exist anymore.
Mm.
And
why
there is another,
would you want the default iteration to consume the vector?
because like was noted before, everything is Rust is focused on let's say performance, so somehow this is seen like the move functionality that is default in when you pass a parameter, for example, to a function. By default, it's, if you just write the normal syntax, is moved. So here is also moving. So why this happening is maybe most likely when you have a code like just imagine you consume some data from the network, like you take it, you parse it, and then you do a for, and then you save it into a DB. Most likely you don't need that anymore because you did your transformations. So then most likely you will also try to discard it, but then the compiler does this for you because this will be the default behavior, because most likely this is what other programs will do. So if you have code which statistically will do like a for like this, most likely you don't need the data after that.
Yeah.
I think this is why they did like this. And for example, you will see. Uh, Let me think if it was mentioning or not. No, it's not. So there are, for example, there were some with lifetimes. When you get to lifetimes, you will see that after you understand it a little bit, there were, so historically in the past there were many cases where you had to use lifetimes. So you have to indicate to the compiler, okay, which is the relationship between these variables and so on. So they seen that it's very verbose. So they have a lot of places where you just put lifetime and the code looks ugly. So what they did, they actually analyzed statistically code and behaviors of how would you use lifetimes in correlation to what. I mean, uh, you pick like a relation between what and what to associate lifetimes, and they actually make it in the compiler. So it's called lifetime elision, and the idea is that there are three rules, and the idea is that if the compiler can determine a clear rule that this was your intention, it will default to that. So you don't have to specify the lifetimes because it will default to that. Okay, if it doesn't default to something that you like or you need, you can specify it explicitly and state it out how would you like. But if it can, and this is the idea. This was based on statistical analysis on actual code. So they didn't just came up with this. They didn't just, I don't know, ask 10 friends and stuff like this. They analyzed public repos. I don't know how they got information inside the teams, inside the other, but they analyzed all code that they could, and they found the patterns, and they come up with three rules and embedded these three rules in the compiler actually, and made it the default behavior.
Yeah, makes
So
sense.
actually, like the developers would do, so they're helping you to do like this by default.
So there, if you write in v dot iter,
Yeah. So
Like
this
this?
no, just
no.
iter, yeah.
Yeah.
So this, for example, this is another
So
trait. So there are two traits. One is
so
into
now v is still available after.
exactly,
Yeah, it's a reference.
because this returns a reference. So this is another trait that you would implement. It's actually called iter, and so iter, and this actually just returns. It has a method iter. You can just go on it. Just control click.
Sorry?
Yeah, you can see the signature, but just so yeah, you can see. Okay, so it's from the impl. Go a bit above to see what is implementing. Just click on line, the first line, the 102, I think, or it's
Where?
on the top on the line 102, because the line 102 is not in this scope. Yeah, okay, and go a bit up.
I don't know this syntax. Oh, whoa, whoa, whoa.
Which one? No, this is a test. Okay, it doesn't show up. Okay, what I want to say, but the idea is that there are two traits, so different traits. One is called iter and one into iter. And the iter, like you've seen, you can go back. If you just move the cursor over. No, just move the cursor over ether. Oh yeah, it's okay. It's okay. If you see, so okay, this returns on ether. Okay, go into the ether, into
Like
the
here.
no into the result of the yes. Struct and go a bit down to see what it implements. Okay, here, look, yeah, look, implements ether. So this is the one. So implements ether. Okay, okay, this is for it. Okay, this is for the same name, but it should have a method ether. Go a bit down. Slice.
Clone as well.
Okay, it's a bit more complicated. So because it makes a slice, so how the ether mode, you see, this is a different structure. So this will be there is another trait which is ether mode which you can implement. But if you would to implement for your structure, there actually are these three traits: into ether, and ether mutable. And
Mm.
actually, this gives you the ability to drain, to consume, or to move all elements, or to just get references. Ether gets you a immutable reference, and ether mut method gets you a mutable reference.
Yeah.
Okay. And by the way, how did you did the the weights? I mean,
Oh well,
generating
I
randomly.
basically, yeah. So where is it? I read the whether the n. Where is it? And here I initialize the weights. So for my weights was a vector,
I understand
and
how did. Okay, okay, yeah, I understand how did.
0 is just the value of how many weights are in this interval. Here and then here I initialize them. Basically, no, not yeah, sort of initialize them. So basically saying that I was going to that specific interval and indexing whenever I would found the random. So that's just how I did the weights. And this is a sort of like a small optimization, not really an optimization. The algorithm doesn't even work without this. What it's doing is just making sure that we don't have weights that are 0 because we don't need them. We shouldn't generate random numbers in those intervals. So I just
Correct,
remove them. And
correct.
and I know from other languages that this is just a lambda which takes a reference to my tuple from the weights and basically
Mm-hmm.
filters them so
Mm-hmm.
that, yeah. I could have also used filter, but quite differently. Uh, Debugging,
The condition is that the way around. Yeah,
yeah, it's the other way around. Yeah.
yeah.
Um, Getting the sum of the weights. This is useful because I've used the cumulative sum, if that's how you call it, whatever,
Mhm.
to to choose the interval that I'm within. Yeah, basically. So I looked around just like before. I generated a random weight, and then what I did, this is, I'll explain what this is later. And what I did here is, where
So
is it?
you have like intervals, and then you have the sum of those intervals. So you have the end of this. So you have the number which corresponds to the boundary of all these intervals, right? And then you generate a
Yeah.
random number between 0 and this number, and then you
Mhm.
see in which interval this number fits. So then that's your uh, uh, I mean the weight,
That's the inter.
the key of the weight that you generated.
And the search for that interval,
I
you are
mean
doing it
the
with
one
I don't
linear search.
search. I don't
the
search for
weight,
the interval.
the
No?
intervals. So the offset. I mean the so each weight or each key of the weights correspond to an interval, and the key that has the weight bigger, it corresponds to a bigger interval on this representation,
Yes,
right?
it doesn't necessarily say that it's gonna be picked, but it
No,
that
no, no.
depends
But
on the random.
it's a bigger interval. So given the
Yeah.
random, it's uniformly distributed, like mentioned before. Most likely, if you generate many times, it will most likely fall in this interval, which is bigger.
So you generate another vector?
No, that's the
No, no,
thing.
no,
I
no,
can
no,
just
no.
use weights.
Yeah.
So yeah.
So he has the. I think Andre, you sent this similar solution when we discussed about this. We actually have a had a discussion. I don't remember if it's in the we have like a weekly challenge. Maybe it's
No,
on
I
the
know
YouTube.
that. I'm not
You
sure.
actually sent
No,
you actually sent also. So you sent this
not me.
algorithm. You sent you
No.
sent also a
But this
link.
was, I also solved this algorithm a long time ago. I got it as an interview question
I
at
know,
some
I
point.
know, I know. So because
And we discussed it, but it was years ago. So
yeah, but we discussed it last year. So I got this problem on another Rust community. They have like meetups, and I posted in some our groups, something like that. And Andrei sent a solution similar to this that I think you did or found after the interview, stuff like that. And then you also send a link with another more mathematical solution, which actually for me took a little bit of time to understand, but it is different. And but this is more human understandable, let's say. So this you can
Yeah.
actually visualize because you see that you actually generate some intervals, and for these intervals you just need to keep the interval boundaries, and when you generate the random you just see in what interval it corresponds, and each of your input values for which you put the weights, because the weights are like a hash map, the value and the weight
Yeah,
corresponding to it.
basically, yeah.
Yeah, and that then each of these keys corresponds to an interval, and you pick the interval and then you go back to the key, so then you know which one was generated. Because for example in that community call, a guy came up with a solution, and he said, okay, it's working, but this is not efficient. I mean, it's using a lot of memory. What he said, so it was like, let's just imagine you have number 1 to 3, and he just said that if I have weight, I don't know, 10, I just put this number in an array 10 times. The other one I put, I don't know, one time based on the weight. So put
Oh yeah,
as
so you
as
copy the. I was thinking about this
yeah,
when I first
yeah.
read the problem,
So
but
it's,
I
it's
thought
it's it's very
that's
similar. So just that he populated a huge array with all these
yeah,
numbers as many
yeah,
times
yeah,
as the weight. So you then he generate in this interval in this array. Of course, then you most likely will fall up in the ones that are many times there. But this is similar solution, but optimizing the idea that you just keep the boundaries of the intervals. So for each interval,
mm,
you just keep for each number in your keys, you just keep actually not even two, you just keep one, because you consider that the end offset of the other interval is the start offset of the new interval.
yeah.
So
But like the reason why I kept the boundaries of the intervals is simply because I always remove the empty intervals which have no numbers in them, and so the order changes. So I thought
yeah,
that
yeah,
well
this is
then I
this
should
is
change the actual
no,
intervals.
no, this is okay, because this is your way to, like what I suggested, I think in the chat, to readjust the weights, right?
Yeah,
Exactly,
basically. It's
because
not very efficient. Like you can see
no, no,
here
it's okay.
that
But the idea is that the other solution, if you just do it one, so the other approach where you just keep the end
it takes
offset of the
longer. Yeah.
interval is just if you generate one time. If you need to recalculate the weights, you will need to redo all these intervals. But in your case, it's more efficient for many generations because you just remove from the list. You
Yeah,
don't
yeah.
you don't need to recalculate all the intervals again. Yeah, so it's okay for this for multiple generate multiple times.
Yeah, we can sort them and but it's not random anymore.
Yeah, 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 no.
So,
Of course, if you want to make it, let's say, optimize the number of how many you generate to minimize. Yeah, you sort them, but the
you
idea
sort
was
them. Defeats the point though.
to learn random ways of
Yeah.
random generation.
Yeah, yeah, yeah. Yeah.
Yeah, and actually you did great, because actually, so that was somehow also in my text there. So first I suggested to use the one from Rand crate because they have this already implemented, and the second, I mean, the other suggestion was, if you are even courageous, more courageous, to implement it by yourself. So you actually implement it by yourself. So
I
because
wasn't at the last course, so I didn't read everything. I didn't know
no, no,
about everything.
this was in the Jira issue
Discord.
for no, no, in the Jira issue for this. So
Oh, okay,
maybe
okay.
if you can open the Jira issue, if you have it, or
Like the GitHub thing.
yeah, GitHub. Yeah. So just look for, yeah, you see here, you can see more on, okay, you can use function and then try to implement. Okay, I write a little bit, but this was the idea. Then and then try to implement your own. So the idea was first you could try to use this. So this actually helps you with this. You just pass it, I think something like an array of weights, like a
Oh, okay.
key value pairs of weights, and then it gives you the numbers, and then the idea was to implement your own. So you actually did that, which is
Mm.
very good.
Yeah.
Do you have your code somewhere online? So I want to
Yeah,
take a
it's a pull
closer look at.
request.
Probably on
Send the
Discord,
link. Yeah, it's on. You send maybe on Discord your
or
pull
I can
request.
send the whole code on Discord
No,
right
no,
now.
it's better to send a pull request because it's contextually, and others can also comment on it if they want. It's even better.
Yeah, the thing is, I don't really know how to do that, and I kind of
No,
have to
no.
go right now.
Okay.
But
Just go to pull requests and just send that link, and we,
uh,
no, in
where?
the left.
Oh, okay,
Yeah,
okay.
there, yeah. And if you can quickly identify yours by username, or it doesn't show. Yeah, it showed the username. So which one is yours?
Where is it?
Uh,
Sorry, I just don't really know how to.
no, there where open by. You see, it
Oh,
says
okay,
open
okay.
by, so that should be your username somewhere.
No,
If you created a PR, I don't know. Did you
no,
create it?
no,
Did you create?
no.
Okay. So just create a PR, but maybe you should read then the guides for the. So
Yeah,
just
probably. Yeah.
yeah. So if you just go to the home to this repo, go to the code or somewhere, or in the title, yeah. And if you go a bit below at the end, there is this right at the end. There is these four students, so you should read that, and there it explains how you should do it. So you should create a pull request and then put it on the Discord, and then find there Andrei. It's something with Andrei. Also your username in Discord.
Yes,
No,
I think so.
Okay,
mine.
so just no,
No, no, but you.
Oh,
Andrei,
okay, okay, okay.
Andrei Bozentano.
I
So
am
just
just curious to see to see the code. Let
yeah.
me
Yeah,
send you a
I can
message on
just
Discord,
send
and
it
you can
to
send it
you on
to me.
Discord. You know, here.
Yeah, that's one.
Well, I can also post it if you want to, but oh
It
no, wait. How
it
do I?
it it will also help if you create a pull request at least, because others then could see your code too,
Uh,
because
yeah,
that is
I'll try
public.
to
So
do that, I guess, somehow.
you can just
Here.
read this and it explains here. No, you just read all this and how to submit your weekly. That's the one. You should follow those steps.
Oh, okay. Well, I'll follow these, but right now I
Okay,
kind of
but
have to
so
go.
no, no, no,
But
not now, not now. I mean, in
oh,
the
okay.
future. But so the idea is that we will end up with a pull request, and the idea is this repo is public, so everybody could see. So you could see each other's pull request and code, and like exactly the situation that Andrei has now, that
Yeah, yeah.
he's curious
For
seeing
now, I
your
just send
code.
it like that because it's
Yeah,
easy
it's
to
okay, it's
understand.
okay, okay.
Yeah, okay.
Okay. Thank you very much. I think it's really is a very good code.
Thank you as well. Yeah.
You're welcome. And yeah, I think we need to we should stop this because it's quite late. And yeah, just send your pull request over Discord. We'll
Hmm?
also try to review all of them, and or also your questions to other chapters and so on. And we'll meet the next week, and then we'll discuss the same
Okay.
the remaining of the codes, the pull request, and the remaining of the chapters.
Okay. Well,
Okay. Thank
thank
you
you
all,
for the
and
course.
you're welcome. I hope it's helpful.
Yeah,
That's
yeah, it
the,
is.
that's the, that's the intention. And yeah, as you've seen, it will not limit to just, or at least what's from my point of view. When I discuss to someone, I can just discuss about, I don't know, we met to discuss about one thing, but you can see in the world many things are related to each other. So I tend to diverge. So okay, maybe in some cases I diverge too much, and if I do, please stop me. So don't be shy or something like that, because this course is not like for me. It's okay for me to try to help you, but it's for you to learn and gain knowledge and gain trust and becoming better. So I'm just like a tool for you. So if I if
Yeah,
I,
I
if
will
I did,
stop you, Radu.
okay,
When you
stop
go
me.
to
Okay,
for too long,
please do.
like to learn more about trust, then
Exactly, please do. But
yeah,
as you see, there are things that you can correlate from other aspects of other programming languages, of other aspects in life and math and physics, because all have some connection, and you can find useful information between all of them. But yeah, it's not practical to just lose yourself in those. So you should just stop at the level that it helps. So yeah, please stop me when I go too far. I tend to do that.
Well, no, I really have to go. I'm so sorry.
Yeah,
But have a good night,
we all
and
go.
it was
Same,
awesome.
same,
Thank
man.
you.
Have a great weekend too. We speak. Bye bye. Have a great week too. Bye bye all.
bye.